Power.
21st century cameras are taking scientists places they've never been.
It's really giving us a new capacity to see.
And they give us access to a hidden world.
We can instantaneously share what happens to us in the field.
Sometimes, researchers even get the animals to take the pictures.
Wow, look, we can actually see what they're doing. We can see what they're eating.
We need hundreds of cameras in this area.
New images and new discoveries.
So it's opened up a whole new area of research because you don't have to be there. The camera does your job.
These images help us captivate and reach people's minds through their hearts.
When the Inuit first settled Baffin Island thousands of years ago, the surrounding waters were teeming with whales. They played an iconic role in the culture here from its earliest days. Our fascination with them has grown since then, but we're only now beginning to see into and understand their lives.
So we're gonna put this on Noah's boat.
Marine biologist Sarah Fortune has brought something new. Something she hopes will explain strange bowhead whale behavior that has always been hidden from scientists.
We see what everyone else sees. The top of the whale's head, their flukes, sort of a really small proportion of the whale's body. And so that means that a lot of their behavior goes unknown.
Joining Sarah is biologist Bill Koski. He's excited to finally get a new perspective on an animal he's been studying for decades.
Most of the studies I've done, I've been flying in an airplane and we're circling whales at 1,000 feet or so that we won't affect their behavior.
But times are changing. Today, there's a whole new way to study whales.
See up now?
It's a state-of-the-art, ultra-high-definition drone.
All right, full power.
The drone hovers just above the whales without disturbing them.
That's such a great view. And can you get a little bit lower, possibly? Awesome, that's great.
Sometimes living 200 years, bowhead whales range hundreds of kilometers. Not an easy animal to study. Until recently, we believed they weren't social animals. The drones show otherwise.
The whales are constantly touching each other. And before, there's no way that we could have seen that, right? It was illuminating to see how these animals are more social than we could appreciate just by observing them at the surface. By having the drone technology, we're able to actually see the full animal. We're able to see how that whale is engaging with other animals, how it's engaging with the environment. So I think it has completely revolutionized our ability to understand bowhead whale behavior, and it's really advancing our understanding of their foraging ecology as well.
Sarah's crew is careful to follow strict guidelines about how close to get with the boat. The drone itself seems to go unnoticed.
It's very exciting to us as biologists to be able to look at things that are not being affected when you're studying them, and by standing off some distance and flying the drone over to take their pictures, we're not impacting their behavior at all.
The team has worked here for 5 summers, with support and collaboration from the community.
We're in Pangertung in Nunavut. It's a beautiful hamlet on Baffin Island, just a little bit north of Iqaluit, which is the capital of Nunavut. And we're just shy of the Arctic Circle, so we could actually walk across the Arctic Circle today if we wanted to. It'd just take us a few hours. It's a stunning landscape here. So we are in a fjord. We have these beautiful steep-sided cliffs. And then the water here where we see bowhead whales, narwhal, beluga, and all of the Arctic marine mammals.
Today, Sarah's on her way to share her findings with the board of the Hunters and Trappers Association.
If anyone has any suggestions or questions that you think we could answer with this technology, that would be really helpful to know.
Difficult to find two more interested groups when the subject is bowhead whales. Today's topic, age.
What part do you study in order to get the age?
Based on our experience with the photographs, the amount of white just in front of the tail, it gets more and more white as they get older. So when you see one with lots of white on it, you know it's a very old whale, probably 150 years or so.
What if there was two bowheads going like this and making sound? Is that mating?
Probably not. When they're mating, usually there's one female and there's about 10 or 15 males chasing her.
Oh.
Yeah. Yeah. There's very few of us who are fortunate enough to work with these whales. So to be able to share this with the local community, I think that that is really important.
There's one question that intrigues both locals and scientists. The bowheads keep coming back to bays with shallow water and big rocks. What exactly are they doing there? Sarah is hoping drone shots will explain a mystery first recorded 170 years ago.
So have you seen any whales in this bay this year?
Oh, yeah.
Yeah? Okay. If you go back to the whaling records dating back to 1845, whalers had made note that these whales would go near shore and they'd rest their heads or their chins upon these large rocks.
Going along this coast, we've been seeing whales rubbing against the rocks in this area.
Okay. Some people thought that they might be feeding. Others thought that they're resting. He's pretty close, Tommy. Around our 11 o'clock.
So we have a whale up ahead. We're heading towards it now.
Set that camera out to the app.
So then I think you want to bring it to our 11 o'clock here, maybe to the bow.
It's starting to come shallow.
It's coming.
A bird's eye view reveals what the whales are doing beneath the surface. This one is obviously not mating. It's moving, not resting. And it doesn't appear to be eating. The researchers realize the whale is using the shallow rocks to rub off layers of dead skin. This is a kind of bowhead spa.
I think it's really cool that the whales have been doing this for so long and that people have been getting glimpses of this and that there has been an interest in bowhead whales and rocks and what are they doing here. But what this camera technology has allowed us to do is to really understand this behavior. Great, awesome. Thanks so much, guys.
Drones allow researchers to see the big picture. But science often happens on a much smaller scale.
We got the location of this burrow through telemetry. So we know that there's an animal inside, and I went to get this camera trap.
Over the last 8 years, biologist Arnaud Debier has done this hundreds of times. He's setting up a camera trap in the middle of the bush.
A camera trap is essentially a device that you can place anywhere, and when something, an animal, passes in front of it, it will take a series of pictures. This is the part I really want to get. So I'm gonna get the motion sensor to work.
Arnaud works in one of the most remote places on Earth. In the heart of South America, the Brazilian Pantanal is the world's largest freshwater wetland. It's rich territory for biologists, and Arnaud's cameras have captured hundreds of species here. But there's one animal that remained hidden: the giant armadillo.
The giant armadillo is almost like a ghost species, the holy grail of animals. And I had never seen one.
In fact, so few locals have seen a giant armadillo that many people thought they were just a legend, adding to the challenge of where to place the camera traps.
Finding a giant armadillo burrow is like looking for a needle in a haystack. It's really, really difficult.
Crisscrossing the vast Pantanal, whenever Arnaud discovered what looked like a burrow for one of his ghosts, he'd set up a camera trap and begin collecting images.
All right, let's watch Tim.
The team spent months sifting through thousands of pictures and videos of other animals visiting the burrows. But there was no sign of the giant armadillo. Then, after months of waiting, the star attraction appeared.
Do you remember when you were a child and you saw your first image of a dinosaur? Well, that's how I felt the first time I saw an image of a giant armadillo from a camera trap.
Arnaud gave her a name, Isabel. Finally, a connection to a real live giant armadillo among one of the oldest mammal groups on Earth.
I could not believe that this species existed, that it was right here around us.
Giant armadillos aren't an easy study, as they are few in number and nocturnal. They can grow up to 150 centimeters long and weigh more than 50 kilos. And then there's that giant tongue.
Yeah, really?
Now, without disturbing the animals, the team could peek into a never-before-seen world. It offered up a sweet surprise. The first ever recording of a baby giant armadillo.
Ele é mole, né? Não acredito. Eu nunca vi esse vídeo também.
It was an incredible experience to be able to see this tiny little white shape. They have no coloring. You can tell that the shell is soft and they're a little bit clumsy, the way they move. All of us got extremely attached to this little giant armadillo with whom we actually had no physical contact. Our whole relationship was through these images. Every time we came to the field, it was an exciting moment. What is Alex going to be doing now? How has he progressed?
Os locais onde vivem os tatus canastra.
The media picked up the story, and little Alex became the project's poster child, as people around the world tracked him through Arnaud's updates.
Podendo pesar até 50 quilos.
Everybody had been following Alex's progress. Alex, I remember telling them when he predated his first termite mound, I remember when he dug his first burrow. So we were almost like you'd celebrate a child's first achievements. We were doing that with Alex.
With Arnaud's discovery of only one offspring every few years, a lot depends on his survival.
One day, we were monitoring him, and we saw that he had entered one of his mother's old burrows. So we set a camera trap in front of the burrow, but he didn't come out that night. And he didn't come out the night after. We saw a vulture land in front of the camera trap. I went and put my face against the burrow, and I smelled a rotting smell, a nasty smell from the burrow. Unfortunately, his story was cut short when he was mortally wounded by a puma.
When Alex was killed at age 2, there was an outpouring of public sympathy.
This little armadillo had actually become quite the ambassador for his species. And his story is very important because people were able to understand how vulnerable the species is and how easy it is to locally extinct a population of giant armadillos because they're not a species that has a high population growth. No, a very low population growth. So any threat, whether it's habitat loss or hunting or roadkill, will have a huge impact on the species.
The Pantanal is one of the world's great reservoirs of plant and animal life. As large as France, this floodplain wetland supports a lot of species and a high concentration of them. Even so, giant armadillos are still very rare here. Arnaud has recorded densities as low as 1 per 100 square kilometers. Now armed with years of camera trap data, Arnaud and his team are confident enough to intervene in the life of an animal in order to maintain the health of the species.
So now we just applied the anesthetic. We're gonna wait a few minutes for the animal to fall asleep. Then we'll take him out to start the procedure.
His excited team must ensure that the tranquilizer has taken full effect.
It's an incredible species. The size, their strength, their smell. It's the highlight of our project. It's one of our favorite moments. This is the moment we get to interact and get to meet the species we hardly spend any time with. Almost all our work is through indirect evidence. We're actually like paparazzi. We're spying on the animal the whole time, looking at images and trying to piece together its life through lots of different techniques. Camera traps, videos, telemetry signals, tracks, foraging evidence, all these different things we try to piece together their lives. And now we get to spend a few hours with the animal. So for us, yes, it's like meeting a celebrity. This is a highlight for us. It's very, very exciting. The white appearing now. This is your first encounter with a giant armadillo. You can see what a prehistoric-looking animal this is. It's the largest of all the armadillos. This particular individual weighs 34 kilograms. They can reach up to 50 in other places. There are 20 species of armadillos, and the giant armadillo is the largest of all of them. They have this huge shell which protects them. And the main characteristic of a giant armadillo are these gigantic claws. They're bigger than the claws of a polar bear. They use these to blast through termite mounds, ant nests, and they can dig very quickly. They break the termite mound with his front claw to remove all the debris. And in a matter of minutes, they can dig a very deep hole. And then they use this tongue, this long, sticky tongue, just like the giant anteater, to lap and eat the ants and termites. To identify individuals, we use the pattern of their scales, which is unique to each individual, just like your fingerprints. The scales, the pattern of the scales on their head is unique to this individual. Vem, arias demoram para tirar as coisas, fazem barulho, atrapalham. Ele já foi correndo, tira as coisas. Lá dentro a gente nunca consegue.
Following a national outreach campaign, inspired by Arnaud's work, the giant armadillo was selected by state authorities as an indicator species, a sort of proxy to diagnose the health of the entire ecosystem.
Thanks to the camera traps, we can really share one of the most intimate moments in the life of a giant armadillo. Camera traps help people create an emotional connection. That saying is true, right? An image is worth 1,000 words.
Beneath this canopy, in the jungles of India, lives one of the most iconic animals in the world. Revered by locals, these ghosts of the forest are a great source of pride and identity. Biologist Ulas Karanth has dedicated his life to them.
I grew up in a small village. The local culture had tiger deeply infused in it. People used to wear tiger masks and dance during festivals. So all this kind of poured into my heart and made me a fan of the tiger forever in my life.
Habitat loss and hunting took India's national animal to the edge of extinction before the government banned hunting and began recovery efforts. A footprint census was step one. But when young Ulas Karanth began studying tigers in 1986, he spotted a serious flaw.
It's almost impossible to identify each tiger individually from its track shape because the speed at which the animal is walking, the soil on which it's walking, all these make massive differences and distort the shape.
You can keep going a little bit more.
It is impossible to wander across hundreds of square kilometers of tiger habitat in a couple of weeks and find the tracks of every tiger. So it simply didn't work.
Ulas had a better idea. Paw prints aren't reliable, but a tiger's stripes are like fingerprints.
What camera trapping allows you to do is to photographically capture a very large number of tigers over very vast landscapes, which you cannot do with any other technique. There are two cameras set on either side of a path where we expect the tiger to actually walk in the evening. When the tiger comes, both cameras fire. The stripes on two sides are very different, so you need two cameras so that you get both sides of the animal and identify it permanently. Once you have a permanent identification, any single flank picture also can be pinned down to that tiger. See, you have to compare the same side. This is the same tiger from a distance of...
As the database grew, Ulas faced a new challenge. How do you quickly and accurately compare a new image to 10,000 others?
And all the stripe information that's in this picture is summarized into a square, captures it in a square, and those squares are compared, and very rapidly across thousands of images. So within a few minutes, once the wireframe is put around, once the model is matched, the stripes are put on the model, then it's very easy to identify.
Over 25 years, Ulas and his team have identified some 900 individual tigers.
And they have some bird tourism. There are other traps taking pictures of the same tiger as he wanders in the forest. It adds up to a lot of knowledge about individual tigers, how they are spread across the land. And once you have this kind of data, what proportion are surviving, how many new individuals are getting into the population, you get a total picture of tiger populations, which is critical for saving them.
The pictures have revealed how far a tiger can range from its birthplace, as far as 180 kilometers. and they've been used to convict poachers, although tiger hunting is no longer the greatest threat to the species.
The biggest threat to tigers is people taking their food away, hunting of their prey by local people. A tiger has to kill one large prey animal every week to survive. Often, tigers disappear not because they have been hunted, but because their food has been taken away, their prey have been hunted out.
Hard data on tigers enables hard decisions about where their populations can truly thrive and how. This is the forest where Ulas has spent his entire working life. When he started, there were only about 75 tigers here. Today, there are 400, thanks in no small part to him and his camera traps. Modern camera technology has the power to reveal many of nature's remaining mysteries. In southern Africa, a unique camera trap study is looking not at one animal, but at the effect predators have on an entire landscape.
So this is...
We're Dam 4, this is ABR 15.
Right.
Researchers Leanna Zanette and Mike Clinchy are using cameras with a special audio playback function to measure the widespread effects of fear.
What we're doing is figuring out the reasons why animal numbers are as they are in various locations and why they're distributed the way they are.
013.
They've set up their camera next to one of the few watering holes in the area.
Animals need to drink water. And you can see in the prints all around that all manner of animal have come down here. All the carnivores have come down here, the herbivores have come down here, everything needs to drink.
So lions at 11:42 on the 23rd of July.
13.
That sound you're hearing is not an actual lion.
Make the terrible noise. There we are.
This camera plays back sounds of predators to trigger a fear response.
Double check.
Data we got.
Excellent. So when the animal walks by, the system will activate the speaker. It'll get that 10 seconds of sound so we can see what the animal was doing just before it heard the sound, what it does when it's hearing the sound, and also what it does after the sound stops.
Okay, sounds good. Good.
They've spent days setting up dozens of cameras and speakers that play sounds from all the different predators here. Now they wait.
Grab the laptop.
A week later, Mike and Leanna return to see what they've got.
Okay, just double check. Let's see. This is, ooh.
Ooh, didn't like the wild dogs.
Frightened animals usually stopped what they were doing and took off. No surprises there. But what these researchers brought to light about the impact of fear itself, even over generations, is truly amazing.
What we've discovered over the years is that this has massive repercussions on a long time scale in terms of the number of offspring that animals are able to produce.
Leanna has done similar studies in North America. Sparrows in British Columbia, subjected to the sounds of a hawk, produced 40% fewer offspring.
This is not good for the country, what's happening here.
And when cougars heard the sound of their predator, humans, their feeding times went down by half. Raccoons, frightened by hearing large carnivores, spent 66% less time feeding, leaving more crabs and fish in the ocean.
Just because they think that there's predators around, there's fewer offspring that are produced, right? The predators aren't killing the offspring. It's just thinking that there's predators around that is causing this massive reduction in population.
Predators are often considered too dangerous to share our spaces with. But without fear of predators, prey animals keep reproducing and eating their way across the landscape. That affects everything living further down the food chain.
The information that we're providing is demonstrating unequivocally that predators are necessary to maintain healthy ecosystems. It's just the beginning of a whole new understanding of how the fear of predators can shape everything. It's unbelievable.
We need hundreds of cameras in this area if we can get it.
Biologist Craig Packer is a pioneer in camera-based research.
I worked in Serengeti for many years. What do we...
Today, he's spreading word about the potential of his latest project, the most extensive camera trap study in the world.
I'm aiming for this program to include camera grids from 50 different sites. This will be able to provide data that we can use to assess how things are going in terms of their conservation. 1-3, we've got literally thousands of these cameras being set up all over Africa. So we have to make sure we know where we are and when. So we're in the Klaseri Reserve. This is camera K013. And this is the 22nd of July. I hope this is the 23rd of July. So we'll have a camera trap grids in Kruger Park, Mountain Zebra National Park, Masai Mara in Kenya. There's cameras in Ruaha in Tanzania. There are cameras in Nyasa Reserve in Mozambique. What I know as a scientist is that we have to measure things. So we want to make it possible for people to have readily available to them reliable information on the abundance and the trends in all of the species within their reserves.
Spotting animals with the naked eye can be tricky in this vast landscape. But leave behind a motion-sensing camera and the scene comes alive. Make that thousands of cameras, and what emerges is a detailed portrait of a bustling ecosystem, revealing how far zebras travel, the gentle intimacy of elephants, and antelope's curious nature. But how do you make scientific sense out of so many images?
The practicalities were daunting. We were generating millions of photographs. And so that's where my graduate students brought this up to the new level, where we truly became a transformative project because they were savvy to this new kind of citizen science where you could put vast quantities of data online and you could have volunteers from all over the world look at your data and then help classify it.
There are now over 140,000 people from all across the globe participating in Craig's project as citizen scientists.
There is a real community around the camera trap process that involves a broader segment of society than we ever could have otherwise.
So far, millions of pictures and over 50 species have been ID'd and cataloged. Countless behaviors, too, like the secret to peaceful coexistence between major predators.
After a very large number of observations at lions at these cameras, we never saw a cheetah show up at the same spot less than 12 hours afterwards. So they waited a good, safe time, and then they might come and actually sleep under the same tree. So it's kind of a timeshare and they're safe enough apart in time that there's no risk of an encounter. If you see the camera trap pictures, you really are being the literal fly on the wall, because there's no sense of anybody there with them when the animal's being photographed. And then there's also interactions between other species that sometimes seem really amusing, like a warthog that looks like it's talking to a gazelle. When you get millions and millions of photographs, you see things as individual images that can really be enlightening. So, for example, a lot of the larger animals are groomed by tick birds. Oxpeckers, they're called. And so these will come along and they'll hop along the back of say a giraffe or a buffalo, and if they find any ticks, they'll eat it. To me, the most fantastic thing about camera traps, why I really love this as opposed to any other technique that has been used before, is that with the cameras, we know where everything goes at night. In some places like the Serengeti, very large animals, they are out in the open plains. Birds that ordinarily roost in trees, we've discovered, like to roost in the crotch of a giraffe, for example. So some of the cameras, you just happen to look up in the photo and there's the underside of a giraffe, and it's like a bat cave, except these are oxpeckers. We've decided that that's a nice warm place to spend the night. And I had no idea they did that. So those kinds of things can just suddenly make you laugh.
So that's the cheetah bird call.
But the real power of Packer's work isn't in individual discoveries, but in the depth of detail about how animals interact with the whole ecosystem. Snapshot Safari aims to answer some critical questions. Can you save prey animals without destroying predators? Do fences help or hurt? In real dollars, how much money does it take to effectively manage a wildlife reserve? And how do you spend it? It's all about taking the guesswork out of wildlife management. It's a revolutionary new tool. This grid of cameras, tracking the movement and behavior of nearly all the animals here, will produce the most complete wildlife census imaginable.
An ideal outcome 10 to 15 years from now is we have a really good view of what's going on. I think the ultimate power of these cameras is that you've got hundreds of eyes out in the field that are collecting information. And you have literally hundreds of thousands of eyes looking at those photographs that are all part of the scientific program to say this is what's happening, this is how well this area is being conserved.
Sometimes, conventional camera traps aren't enough to capture all the data that scientists need. Caribou biologist Art Rogers and his assistant are heading into the bush north of Wawa, near Lake Superior. They're chasing the signal from a caribou camera which has stopped moving.
I think it's up over the hill, Blake, or?
Just within about 10, 15 meters.
There's a real urgency to seeing what the camera recorded before it automatically detached. Woodland caribou are threatened with extinction in Canada. They need large, intact swaths of boreal forest to survive, and that habitat is disappearing. To preserve the species, Art must nail down exactly which areas most need protecting.
One of the key things we need to know about caribou is their food habits. We can learn a lot about their habitats they like to use just through telemetry locations of collared animals. But we wanted to learn more about their actual diet. What are they eating? What kinds of habitats have the food that they really need? Oh, there it is. There it is. There it is.
Because the caribou are constantly ranging over hundreds of square kilometers,
not too bad.
Camera traps weren't an option.
Yeah, we got the collar. We're just taking some shots around.
Caribou cam had to be something completely different. In fact, they'd need to recruit the animals to film their own lives.
And so we proceeded with the development of these camera collars, as we call them. It's a GPS collar, a normal GPS collar that has a camera unit attached to the bottom of it that records information about what they're eating in quite a bit detail.
That's May 20th. Okay.
Yeah, back in May.
Yeah. So
Over 4 years, researchers mounted lightweight cameras on dozens of caribou, set to record for 10 seconds every 10 minutes during morning and evening feeding times. What you see in the middle of the picture is the chin of an adult caribou. Not Oscar-winning cinematography, but to Art Rogers, the footage is simply amazing.
Wow, look, we can see this. We can actually see what they're doing. We can see what they're eating. It allows you to accompany the animal on its journey through life.
A life that includes eating a lot of lichen.
In the summertime, close to 50% of their summer diet is still lichen. And that surprised us because we thought, well, once, the world turns green and all of the other plants and leafy vegetation comes up, that they would switch on to the easy stuff, relatively speaking, and relatively more nutritious. They graze along the top of the lichen mat and maybe just take the top centimeter or two, a couple of centimeters, sort of the newest growth on the lichen. And in a sense, you could call that sort of farming the lichen. They're leaving some behind to grow back for another time. And we've seen some other feeding behaviors, in particular feeding on mushrooms. She eats a mushroom, she walks 10, 15 meters, picks off another mushroom, looks for the next one and goes and takes that. There's just no other way we would have ever known that or seen that. As you watch more and more clips, you start seeing what sort of habitat they're moving through, or this young calf, just born, newly born calf, trying to stand up for the first time and mom drying it off.
Collar cams uncover exactly which habitat is most important for calf bearing and rearing. They reveal that new mothers stick close to nearby islands. If mom senses a predator, she can swim her calf to safety. Caribou cam serves up several surprises. Caribou don't stay hydrated in winter simply by eating vegetation and its snow cover. They use their front hooves to mush up snow and ice until water comes up from beneath. A natural slushy. Cameras show firsthand how caribou live in the landscape, which areas are critical for food, for safety, and for rearing their young.
And when we know what those habitat types are, we can start planning for those in terms of land use planning and forest management and other industrial developments, and make sure that there is enough of that provided to ensure the persistence of caribou into the future and to conserve caribou on the landscape.
Today, cameras take us everywhere. They can withstand the pressure of the deep sea. In the Pacific, off Vancouver Island, unmanned cameras are 2,200 meters down, filming fantastic creatures few people have ever heard of, let alone seen. At this bat cave, high-speed thermal cameras reveal a hidden world. Slowed down, the images allow scientists to track individuals, count wing beats, even watch the bats interact, all in the pitch black. This 36-hour time-lapse in the savannah shows just how many animals are fed by a single kill. And remote cameras can be left behind in the coldest places on Earth, like Antarctica. Penguin Watch uses a network of 75 weatherproof solar-powered cameras to record the secret lives of penguins and the impact of climate change on their world. For scientists and filmmakers, catching wild animals in action is serious business, though some of what gets captured is just plain silly. It was nearly a century ago that an ambitious young photographer named George Shiraz III decided that he wanted to spy on animals. Using crude tripwires and single-use flashbulbs, he became the first to succeed at photographing a hidden world. Something scientists and filmmakers have been trying to improve on ever since.
Action!
Today's camera technology is also playing a profound role in conserving species.
Okay, there he is.
From deepest Africa to the Arctic Circle. That's because seeing is believing.
If someone who is living down south and whose daily life isn't really affected by environmental change, to be able to see imagery of the animals that are reliant on their natural environment is really powerful. And I think that's one of the benefits of this technology.
One of the key applications is to contribute to the development of an Eastern Canada, West Greenland bowhead whale photo identification catalog. And this is something that Dr. Bill Koski is leading with colleagues at Fisheries and Oceans Canada. What they're doing is using the drones, so they're taking aerial images of the whole whale, and then Bill is using unique identifiers for each whale to identify the total number of whales. And then with this catalog, we can look to see how many of the same whales come back to the habitat next year and the year after that. And this is really an important step to contribute towards the conservation of the species. Because bowhead whales in the Eastern Canadian Arctic were nearly decimated by commercial whaling, it's really important to document the whales over time and just to be able to monitor how the population is doing, especially because they're living in the Arctic. And this is a place where climate change could be threatening their future.
It's funny, some of these ferns with the snow on them almost look like a rib cage.
On the shores of Lake Superior, Art Rogers is back in the woods.
Oh, there it is. There it is.
He's tracking down more caribou collar cameras, and he's hoping what's inside will inspire people to care about animals far removed from their daily lives.
So one of the great benefits of this camera technology is that it provides an opportunity for the public to bond with these animals so that in the longer term, we can get that public support and that public feeling for the need to conserve caribou now and into the future.
When so much is invested in tiger conservation, people even sacrificing their lives for tigers, we need to know accurately whether what we are doing is working. And it's only accurate audits of tiger numbers using camera trapping that allows you to know whether we are succeeding or failing.
Camera traps are, for a field biologist, what a microscope is to a microbiologist. It helps us see things that we can't see with our own eyes.
And sometimes things that we don't anticipate. With his cameras trained on the burrows of giant armadillos, Arnaud Debier discovered that they are critical to a host of other species.
The giant armadillos, they're giving homes to other species. Giant armadillo burrows are used by other species as a refuge against predators, as a refuge against extreme temperatures, as a place to forage. And you can see through our camera trap images that so much happens. In fact, by placing a camera trap in front of a giant armadillo burrow, you can document a lot of the diversity in that habitat.
New species are sometimes being discovered with camera traps. Animals are being found in places they were not expected to be there. So it's opened up a whole new area of research because you don't have to be there. The camera does your job.
And with each new image, each unique window into the natural world, another chance to connect with us.
These images help us captivate and reach people's minds through their hearts. We can show people, look, here is this incredible species, and it's right here, right now, and if we don't do something, we will lose it.